we're going to talk about multiplying binomials. Right, Jason?
Yes.
Okay. Brandon, what's a binomial?
It's a polynomial.
Correct. So now we have an example. I'm going to start. And I think already know how to do some of these already. So let's review a little bit. Yeah, we did this before also too.
Yeah.
So we're going to multiply these binomials. Let's see if you remember. We just have to basically, by the way, do you think it's a good idea to change everything to addition?
Yes.
Okay, so I did that. And I told you to multiply. First, what are we going to multiply? Let's see if you guys remember. X times what first? X. And then remember I told you to draw the arrow like that? So x times x is x squared. And because we change everything to addition, it's nice because between each of these terms, you have what in between them? What symbol? Addition symbol, right? And then x times negative 4, of course, is negative 4x. I'm going to put parentheses. I'm done, right? No, that's how you get, I haven't multiplied 5 yet. So 5 times now, x. Again, in between each of these terms, we have addition symbol. Then we get 5x plus 5 times negative 4, which is? Negative 20. And this is very simple. Like you guys said, this is, what is this? Plus x, right? Minus 20. Right, at the end, by using the definition of subtraction, plus negative 20 is the same thing as minus 20, right? So this is very simple. This is something you've done before, right?
Yes.
Okay. So that's pretty straightforward. Can I go to an example 2? Turns out that this section is pretty straightforward. You just have to multiply these binomials. That's it. May I move on to example 2? Yeah. Okay, everybody try example 2. It says 3x plus 4y times 3x minus 4y. Do you think it's, again, a good idea to change it to addition? This is all review, isn't it? Go ahead, everybody try. I'll wait. Okay, here we go. So, how many people change it to addition like this? Very good. Somebody tell me what to write. Oh, I'm sorry. Chuck, what do I get? Tell me what I get.
Yeah.
First, when we multiply,
squared
good, plus,
negative 12xy
good, plus.
12xy
That's right. Hold on. Oops. I'm not. Okay, here. Right. And then, plus.
negative 16y squared.
Good. Okay. We're done, right, guys?
No.
No, of course not. We have like terms. Mimi, what do I get?
Not 9x squared minus 16y.
You got it. Any question?
No.
Okay, turns out this one's sort of interesting. Do you see how the middle term went away? This happens every time if anybody wanna clear? Okay, listen, hold on. Before you say clear. You see how the middle terms they canceled out, Jason? We have negative 12xy plus positive 12xy. You see how they canceled out because these are like terms?
Yeah.
This always happens. When does that happen, Claire?
When they're both like the same number, but one's negatively.
That's right. When you're multiplying two binomials, right? They look exactly alike except one of them is addition, the other is subtraction. Does that make sense? Okay. So it turns out that always happens. Okay, so every time you have two binomials that look exactly alike, but one of them is addition, the other is subtraction, the middle term always goes away. It kind of makes sense because you know how one of them is going to be negative, the other is going to be positive, and then you're going to be multiplying same things together. But you see this. Do you remember the homework from last time where you were doing distributed properly backwards? Soon we're going to be doing 9x. If I had from this answer, we're going to ask you what was this polynomial before it got all multiplied out. So we're going to ask you to figure this out. How do you go backwards this way?
Yeah.
So when you have a polynomial, we're going to ask you to write it as a product. What is that called when you write something as a product? Start with F? Factoring. So we're going to ask you to factor these polynomials. And you guys might say, well, how do you do that, right? I mean, it looks sort of impossible at this point, but turns out we could do this, okay? And that's what we're going to be doing. And some of you already know how to do this from last year. You guys did this part of it. Anyway, so we'll definitely go over them, okay? Soon. Okay, let's go to example 3. Oh, before I go to example 3, let me ask you something. Let me show you something. Actually, let's do example 3 first. Let's do example 3. Then I'm going to tell you something. Okay, 6x squared minus 2y times 3x squared minus y. Very simple. Okay. This time, they're both, the two binomials have subtraction in the middle, but that's not that big of a deal. Okay, go ahead, everybody try. Okay, do you all agree that okay, first of all, did you all change it to addition? Yeah. Okay, good. Then how many people got 18x to the fourth plus negative 6x squared y plus negative 6? By the way, did anybody put down negative 6y x squared? Do you think that's a good idea? No, you want to write them in what kind of form? Yeah, and standard form, alphabet, yeah. Because if you don't, they don't look like they're like terms. So please be careful. If you have a chance to write them in alphabetical order, right? Sort of in standard form, do that so that the terms look like they're like terms. Otherwise, you may think that they're not like terms. Plus, of course, you get negative times negative is positive, positive 2y squared. So did you all get the answer as 18 x to the 14? Well, x to the fourth, not 14. 18x to the fourth minus 12x squared y plus 2y squared, ratio n. Good. This section is pretty straightforward, isn't that right? Any question? All right. Good. Now let me tell you something about these trinomials, okay? So each of these terms of a trinomial, like 6x squared plus 7x minus 20, has standard name. Each of these terms. How many terms do I have, by the way, in this polynomial? There are 3. And the term with some variable squared is called something, and then the term with x to the first power is called something, and then the term with just number. It has a standard name. Let's start with the last term. By the way, what is my last term?
20.
How many people say 20? Raise your hand. How many people say it's negative 20?
Oh yeah.
Yeah, it's negative 20, isn't it? Because terms are separated by an addition sign. So if you were to rewrite this addition, you see clearly that the last term is negative 20. Does that make sense? Anyway, the last term has a name. If you have number by itself in the trinomial like this, anybody want to guess what it's? Yes. Constant term is correct. Very good. Because it's constant, right? Is negative 20 sometimes 5 or something? No. Negative 20 is always negative 20. It's constant. It doesn't change. What about 7x, that term with x to the first power? It starts with L. Anybody want to guess? It's called Li.
Wait, don't tell us.
Like.
No. Kali got yeah. No. Yeah. Linear term is correct. So the term with x to the first or something to the first power, okay, it's called linear term. And 6x squared is called the. It starts with Q.
Quotient.
No. Okay, that's a good guess.
Quickly.
No, it's called quadratic.
Yes.
So write that down.
You guys are smart.
So if you didn't know, now we know. It's not a big deal. It's just I'm just telling you what they're called. Okay. So later we're going to be referring to these terms as quadratic, linear, or constant terms, and you should know which one I'm talking about. Does that make sense? So write that down. So notice how the the quadratic term has x to the second power, right? Linear term is the one with x to the first, right? That invisible one. And then constant term does not have any variable, okay? Just some number. Anybody need more time to write? May I move on? Almost? Okay, take your time. So let me switch your gear a little bit and ask you something. Some of you might think, oh, that's sort of too easy. Okay, what about this? If I have 2 times 3 times 4 in parentheses like this, how do we multiply? Ray, raise your hand, how many people say, yeah, you distribute, right? So 2 times 3, and then 2 times 4, you multiply. That's how you get it wrong.
What?
I don't. Okay, right. Okay, listen. Hold on. Shh. Give me a sec. Many times, listen up. Many times people would see this and go, okay, let's distribute 2 times 3, 2 times 4, and then multiply things inside. When do we distribute? If you have more than. Whenever you have more than 1 term. How many terms do you have inside the parentheses?
2.
Terms are separated by. So how many terms do you see inside the parentheses? 1. Do you see any addition symbol anywhere? No. Guys, please do not make this silly mistake. Okay? Because really, what is the answer for this? You follow the order of operation, right? What's 3 times 4? 12 times 2. Look what happens if you were to distribute. 2 times 3, what do you get? 2 times 4, what do you get? What's 6 times 8? Is that 24? No, it's not. Does that make sense? Class, you only distribute if you have more than 1 term inside the parentheses. Do you understand? So we multiply 2 at a time, don't we? Right? We multiply 2 things at a time. By the way, multiplication, it has the property called commutative property, right? Therefore, it doesn't matter which ones you multiply first, but you need to multiply 2 at a time. Does that make sense? You could either do 3 times 4 times 2, or 2 times 3 times 4, or 2 times 4 times 3. You should always get the same answer, which is 24. You understand? Right, guys?
Yeah.
Please don't do that. Just because you see parentheses, people just start distributing. Get it wrong. So take a look at this example. N times n minus 3 times 2n plus 1. Okay? How many things are we multiplying here? Three factors, right? So we multiply how many at a time? We multiply 2 at a time, guys. Okay. Do you think I should distribute this n to the n minus 3 and n to the 2n plus 1? Who say yes? That'll be wrong. If you to distribute n to both of these, that'll be wrong. You multiply 2 at a time, I'm telling you. Right? So you could either do n times n minus 3, right? Then whatever you get there, times 2n plus 1. You don't multiply n again to 2n plus 1, do you? That'll be wrong. Which two of these factors should I multiply first? Anybody? Since we're talking about multiplying binomials, which two? It really doesn't matter which two you multiply first, but what do you think is a good idea to do? Yes, Dana? Oh, in other words, can I multiply these two first here? 2 binomials? Do I have to? No. But can I multiply these 2 binomials first and then multiply n to whatever answer I get after I multiply these? Is that okay? I think that's the best, that's easiest way, but it doesn't really matter. So why don't you do it this way since I did it this way? Go ahead, everybody multiply the 2 binomials together and then multiply n. Okay? Now, could I have multiplied these first 2 factors first if I wanted to? Would it change the answer at all? Class? No, it wouldn't, right? All right, go ahead, everybody try. So let's start. How many people got n times 2n squared plus n plus negative 6n minus 3? Good. Do I have any like terms?
Yes.
By the way, can I leave out this n somewhere? Can I just get rid of this n? No, you're still multiplying that n. But I'm multiplying 2 at a time, right? Like I said, you could multiply the first 2 factors or the last 2 factors or the first and the third factor. Doesn't matter. But I think binomial times binomial is easiest. Then multiply that n, because multiplying a monomial is not easy at the end, right? I don't know. Then when you multiply this out, somebody tell me what I get. Inside the parentheses, what does that become? Same people? Can somebody? Angel, what do I get? What happens inside the parentheses when you simplify? Yeah, after we distribute, no, don't we have like terms inside the parentheses? What are the like terms? Yeah, what's negative 6n and n? Negative 5n. Okay, does that make sense? So we get negative 5n times n, the whole thing times n, right? Do we know how to multiply monomial times polynomial? Okay, what do I get, Kevin, when I multiply this?
2n cubed minus 5n squared minus 3n.
That's right. And how many people got, after you simplify, using the definition of subtraction, 2n cubed minus 5n squared minus 3n? Any question? Do you see how we need to multiply 2 at a time? Right? One of the mistakes that people make is they multiply this n to the first binomial and then also to the second binomial. Is that right? No, you multiply 2 things at a time, right? If you're multiplying 3 things here. Jason, question?
So after you do the FOIL and you multiply those,
Yes.
then you still keep the parentheses and then you distribute.
Yeah, you still have to keep the parentheses. You're exactly right. Because I'm still multiplying this n to the rest of the whole polynomial that I have. Does that make sense?
Yes.
So that's really important. Otherwise, if you don't, then you'll be wrong. Right, guys? I am multiplying this n times this whole thing after what I multiply, these 2 binomials, right? Carolyn, question?
I still don't get why you can't just distribute
You can. How do you want to do it? Tell me what to write.
like n squared
Right.
plus negative 3n
Uh-huh.
times 2n plus 1. Can you do that?
Yeah, that's totally fine. I said you can multiply any two first. So if you wanted to, yes, you could do n squared minus 3n times. Could we do this, guys? 2n plus 1. Could we do it this way? I just told you this fine, right? You can multiply the first two. Carolyn, if you do this, you get the same result. But I'm just saying, why not multiply these two binomial first? Isn't that a little bit easier? I don't know. It doesn't really matter. So after you do this, if you multiply it correctly, right? You do this times this times this. You should get 2n cubed minus 5n squared minus 3n. You get the same result. Okay? Is that what you're asking? All right. Any questions? Does that make sense, guys? All right.
Yeah.
Okay, now let's do example 5. This is our last example. Now, how is this one different than all the other examples that we did so far?
Equation.
There you go. We have an equation. So that's what we do with the equation. What do we do with the equations, class? We solve. What do we do with expressions? We simplify. Go ahead and solve. Okay, I'll wait. So, on the left side, when you multiply that binomial, by the way, I changed it to addition. When you multiply that binomial, you should have gotten x squared plus 9x plus negative 4x plus negative 36. On the right side, you should have x squared plus negative 3x plus 5x minus 15, which is plus negative 15. And of course, when you simplify, you have the two like terms. How many people got x squared plus 5x on the plus negative 36 on the left side? X squared plus 2x plus negative 15 on the right side? Good. If you didn't, go ahead and fix your mistakes. You should have got, oh, okay. Michael, what do I do next? How do we solve? Yeah, you need to gather all your like terms first, right? So you got x squared on the left side, you got x squared on the right side. That's good, because what's going to happen when you subtract x squared from both sides? Cancel out. That's a good thing, because we don't know how to solve equations with x squares yet. Okay, we'll get there, but not yet. Then, of course, let's gather the x's. Should I get rid of 5x or 2x? 2x, subtract 2x from both sides, one that's smaller. Then we get 3x plus negative 36 equals to negative 15. Add 36 to both sides. And you get 3x equals to 21. Divide both sides by? 3. How many people got 7? Some of you said 17. It shouldn't be 17. It should be 7. Any questions? Yes.
For example,
Yes?
what if we have...
Hold on. Okay, guys, we have a question being asked here. Could we have... Thank you. Go ahead.
Okay, what if we had a problem where it was like, hang on, where we have to, where it's on like, it's a equation, and on the right side it says in parentheses x minus 3, but then there's the square. We distribute that to the x minus 3.
It says x minus 3 in parentheses squared.
Yeah.
Then you would have to do what? X minus 3 times x minus 3. That's what it means, right? If you have x minus 3 whole thing squared, you got to do that, right? Does that make sense? So that's a good question. I think you're referring to your homework question. If I had something like this, x minus 3 squared is equal to, I don't know, 5. What do you have to do? Is this x squared minus 3 squared? No, it means x minus 3 times what? X minus 3, isn't that right? How many terms are you going to get when you multiply these binomials? 3 terms. Does that make sense? A lot of people think that x minus 3 times, right? X minus 3 whole thing squared. It does not mean x squared minus 3 squared. That'd be wrong. Okay, you don't distribute the exponent. That's only when it's multiplication inside. If you have only one term. Okay? Any other question? Can you do something like this for your homework tonight?
Yes.
All right, good.